Hey guys, here we have a grade 12 maths literacy paper 2 that was written in November 2022, 150 marks, 3 hours long. If you want to download the paper, just check the description below. So with this question, there will be more questions that carry on after this. So there we have the first question, second question, third question, fourth and fifth question. Okay, so 5 questions. So we are given various clocks indicating the different times. It says, first question, which one of the following, X, Y, or Z, best describes the time displayed on each clock? Okay, for X, 9 minutes to the next hour, 45 minutes to the next hour, a quarter to the next hour. Okay, let's have a look at these clocks. Well, if we look at all of them, this one here is 5:45, this one's 12:45, this one is also 12:45, this one is, what's that, probably 2:45. This one is 4:45. Okay, so we get the idea, right, that they all have 45. So if you are talking to someone and you want to tell them the time, and if you look at your watch and it says this, you're not going to say 45 minutes to 4. No, you're going to say it's a quarter to 4, or a quarter to, for example, if we had it like this, you would say a quarter to 8. Okay, so Z is going to be the correct answer. You're going to say a quarter to whatever the next hour is. You wouldn't say 45 minutes to the next hour, and you definitely wouldn't say 9 minutes to the next hour. Okay, so Z is the answer there. This question says, name the 2 time formats. So when I read that at first, I originally thought they were talking about like the different types of ways they can show the time, like analog, digital. But if you look at it carefully, they're saying name the 2 different time formats. So you get, for example, you get 24-hour time. So 24-hour time. That's, for example, if, let's say, 3 o'clock in the afternoon, you would say 15:35, for example. Okay? But then you also get, so that would be something like this. You see, that's actually 4 o'clock. Then you get 12-hour time, where 3:45 in the afternoon would be shown as that. So with let's say with 24-hour time, you go 20. You have 24 different. Or you use all the numbers up to 24. So for example, use 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, and then it goes 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, so that's 11 o'clock at night, and then when midnight, we usually go 00.00, that would be like midnight. But you see how we're going all the way up to 23 or 24, if you want to think of it like that. So that's why we call it a 24-hour time. But some people prefer to only use a 12-hour time. So then what happens is that your clock goes 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5, 6, 7, 8, 9, 10, 11 o'clock, and then 12 o'clock at lunchtime. Then when it's 1 o'clock in the afternoon, it just goes 1 o'clock again, 2 o'clock again, 3, 4, 5. So it repeats these numbers again, but it never goes higher than the number 12, and that's why we call that 12-hour time. Okay? Hope that makes sense. Alright, this question over here says, write down in words the time displayed on clock B. So clock B, it's 12:45, right? So that means it's a quarter, so it's nearly 1 o'clock. So it's quarter to 1. So we can say quarter to 1. And how do we know if this is afternoon or if this is 12 o'clock in the morning, like midnight? Well, it's not midnight, because if it was midnight, it would be 00.45. Okay, that's midnight. But this is definitely in the afternoon, and they want you to be able to explain that to them. So you're going to have to say here that it is quarter to 1 in the afternoon, Okay, you are also allowed to say 15 minutes to 1. So you can also say 15 minutes to 1 in the afternoon. Okay. Alright, this question. Write down the number of clocks that clearly indicate a time in the afternoon. Okay, so with this one over here, we definitely cannot tell if it's afternoon. This one we said is afternoon, so that's a yes. This one we have no idea if it's in the afternoon or the morning. You can't look at that and be able to tell. You can't look at this one either, so that's a no, that's a no, that's a no. This one is definitely afternoon because that's 4 o'clock. But if it was 4 o'clock in the morning, it would say 04. Okay, so that's afternoon. This one here might be afternoon. It might not be because they might be using a 24-hour time. They might be using a 12-hour time, but we don't really know. And they said clearly, so that's not a clear one. So that's definitely not clear, and that's also not clear. So it's only going to be B and E. So to write down the number of clocks, that would be 2. This question over here says convert 16 hours and 45 minutes to minutes. So 16 hours and 45 minutes. They want you to change that into minutes. Well, this part is already changed, right? So that's easy. So we can leave that one. We just need to change this one. So 16 hours, we need to change that into minutes. So remember, there are 60 minutes in 1 hour. So if you have 16 hours, then how many minutes would that be? Well, you can just say 16 multiplied by 60, and that would give us 960 minutes. So now we have 960 minutes over here, and then 45 minutes over here. So you could just add those two together now because they're both minutes. So you could say 960 plus 45, and that would be 1005 minutes. Okay, so with this question, please keep in mind that the questions do carry on. So the first question will be over here, then there's another one, and another one. So let's get started. So I think pretty much they're just showing us how to build like a deck chair. Okay, a deck chair. So it says, illustrated below are the steps and some instructions to assemble a deck chair. To assemble the deck chair, the wooden pieces are joined together using fasteners. Now those could be screws, bolts, washers, and nuts. Do they say bolts? Oh, bolts, different types of bolts, I guess. There are 32 pieces in the packet. Each bolt is secured by a nut and a washer. Okay, so got it. So it says for the first question, determine the number of type C bolts. Now remember, they tell us that altogether there are 32 pieces. So there's 8 here, 6 here, 8 here, 8 here. So we can see what those add up to. So let's just quickly go add those together. So 8 plus 6 plus 8 plus 8, and that should give us 30. Well, not should, it does. So that's 30. But we are supposed to have 32 pieces in this packet because they told us that over here. So if there are 32 pieces, then that means the number of type C bolts would have to be 2, right? Because 32 take away 30 is 2. Okay, so moving on to this question. It says, state the number of nuts left over after step 1 is completed. So here is step 1. Let's see what they say we should do. Okay, so in step 1, it says attach the seat. Okay, so attach the seat using bolts B, which is these ones, E, and washers to the 2 front legs. And then it says attach the long brace using the screws A. Okay, so we're going to be using, they want to know how many nuts are going to be left over after we complete this step over here. Now, if you look carefully, they are using 3 bolts Okay, there's 3 bolts over there. 1, 2, 3. I'll zoom in quickly so you can have a better look. Alright, so have a better look there. There's 1, 2, 3. And then on the other leg, there's also going to be 3. Okay? It's a bit difficult to see, but this was confirmed when I had a look on this side of the picture as well. You can see there's 3 holes there. So they're going to be using 3 bolts on either side. Okay? So they're going to use 3 bolts here and 3 bolts here. But I don't know if you've ever built anything before. When you use a bolt, then you also have to use a washer and a nut. So here's an animation. See, so there's the bolt. And then you always put a washer on first. And then you put the nut. Okay, and then you tighten up the nut like that. Okay, so it's bolt, washer, nut. Okay, so what we see here then was that we're going to use 3 bolts on that side. So that means we're also going to use 3 washers and 3 nuts. And then we're going to use 3 bolts on this side and also 3 washers and 3 nuts. So in total, how many, what do they want here? How many nuts are we going to use? Well, we're going to use 3 on the side, 3 on the side. So we will use a total of 6 nuts will be used. How many do we have in total? Well, there's 8. So if we say 8 minus 6, that means 2. So there will be 2 nuts left over. 2 nuts, let's say, remain. Okay. Okay, this question says, name the last piece required to complete the assembly of the deck chair. Okay, well, I think if you look at step 1, they do that. Step 2, they do that. Now, what is the difference between step 3 and step 4? It looks like what they're doing, you see in this picture here, or it says attach the back to the seat and arms using the screws, and then look at these 2 pictures though. There's no short brace over here. I mean, there is a short brace over there, but there's no short brace over there. So that is the last step. It's to add a short brace. You can just say here, add a short brace. Alright, so just to remind you, these questions are going to carry on. So here's our first question, second question, third question, fourth question, and lastly a 5th question. It says here, below is a map of Northwest showing destinations, towns, cities, and interleading roads. Okay, so this is an area that I'm not too familiar with, to be honest. I haven't been, I've been to these areas, of course. I mean, it's quite a large area. Where have I actually been? Okay, I've definitely been Limpopo. I've definitely driven to Pretoria before. Where else? Does any of this look familiar to me? Not really. I've heard of these places, but I've never been to really. Yeah, I live in the Western Cape. I was originally born in Durban, well, just outside Durban, called Ladysmith. But yeah, this is an area that I'm really not that familiar with. Although Sun City, I've been to Sun City. Went there when I was in grade 7. To Sun City itself, where we went into went down all the water slides and all of that. It was a lot of fun. It was actually so fun. Okay, but let's move on. So for this first question over here, it says identify the type of scale used in the map. Okay, so the scale is over here. So this type of scale where they show it like that, they usually have something like that with lines like this, and then they'll say I don't know, here they've got, for example, 20 kilometers, 40 kilometers. So whenever they show it like that, it's called a bar scale. Okay, because you can think of these as like little bars, but they also call it a line scale, or you could even call it a graphic scale. We get other types of scales. For example, if we use something like 1:50, that's usually called a number scale. But for this question, you could choose any one of those. Okay, it's not a number scale, but you can choose any one of those. Okay, so let's have a look at this one. Name the province that lies east of Northwest. Okay, so remember, east is, so we got north, south, now we shall eat. So east is on the right hand side, okay? So they said of Northwest. So if this is the province of the Northwest, then we need to find the province that is to the right, and so that would be Gauteng. For your own information, remember South Africa has 9 different provinces. That would be the Western Cape, Eastern Cape, Northern Cape, Southern Cape. Okay, that was a joke. Northwest wasn't that funny here. Northwest, Mpumalanga, Limpopo, Free State, KwaZulu-Natal. I'm just going to say KZN. So that's 1, 2, 3, 4, 5, 6, 7, 8. One more. Gauteng. Gauteng. There we go. Okay, so those are the different provinces that we have in South Africa. So the answer for this one, by the way, should have written it down, is Gauteng. So here's our next question. It says, identify the national roads passing through Vryburg. Okay, Vryburg, where are you? Okay, so here's Vryburg. Okay, so that would be over there. Now, the national roads have an N. Sorry, my nose is a little bit blocked, so you might be thinking I'm saying M, but it's N. So that's going to be all the roads that go through. So that one goes through, so that's the N14. N14. This one over here as well, N17. Oh, and here they also remind us that a national road has an N. I think it's those two, hey, because this one over here, that's not a national road. This question says, write down the number of destination towns as shown on the map. Write down the number of destination towns shown on the map. Now, a destination town, they are showing us here in the key, is any town that has like a big white block like that, okay? So that would be, for example, Uppington, Francistown, Tambasimbi, Polokwane, Durban, Bloemfontein, Kimberley. So, and the reason they're called destination towns is because they're not on the map. But what they mean is, you might be looking on your map over here, but you know that if you want to go to Uppington, you would follow this road, and eventually, maybe somewhere over here, you would see Uppington on the map. But Uppington is not on the map at the moment, okay? So 1, 2, 3, 4, 5, 6, 7. So that's going to be 7. Here's the next one. Measure in millimeters the direct distance. So as the crow flies. You know what that means, right? So we know that if you drive from here to here, you're going to go along the road, we hope. Okay, so like that. But when we're measuring, sometimes that takes a little bit too long. So what we do is we pretend that we are birds. And hey, everyone's got to have a dream, right? So we can pretend we're a bird. And then we just pretend that we fly completely straight. Okay, that was a bit of an embarrassment. So we fly completely straight. So we forget about the fact that the road goes like this. Okay, so we go just like a bird. That's why we say as the crow flies. So, measure in millimeters the distance as the crow flies from Bloemhof. So where's Bloemhof? So Bloemhof is, I see it there, but we got to know which one it is. Is it this little dot? Yeah, it'll be this dot over here. So that's Bloemhof. And then we're going to Lichtenburg. Okay, so Lichtenburg is over here. Okay, so now, obviously I've put this map on my computer screen and I've probably made it bigger or smaller or whatever. But when you guys when you guys are sitting in a test or an exam, luckily you'll have it in front of you. So you're going to measure it with your ruler, right? So I can't measure it with my ruler now because the lengths and everything, I don't know, it might just cause a bit of an issue. Or it would probably give the same answer because the scale would also be stretched by the same way that I stretched the map. But if I measure this, for example, and I say 17 millimeters, and then you measure it at home, you might get a different value, right? So I'm rather just going to tell you what the answers that you need to be getting are. So you're going to take your ruler, okay? And you're going to measure the distance from here to here, and that distance should be anywhere between 38 and 40 millimeters. You are allowed to get anywhere between those values, okay? The actual answer is 39, but then they said you're allowed to go one less and also one more, okay? So you can get anywhere between there. Okay, so I'm going to pretend that we got it perfectly, and we got it as 39 millimeters. So with this question, the first thing I want to let you know is that the questions do carry on. So here's the first question, the next one, the next one, the next one, the next one, and then lastly. So there's 6 questions we're going to be looking at. So let's see what this is all about. So it says Annexure A, which is this one, shows a restaurant seating plan. So we are looking at the view of a restaurant where people go to have food and whatever. So, okay, Kevin, you really don't need to explain what a restaurant is. I'm sure people understand that. Okay, so it's just a restaurant. Guys, we understand that. Okay, so first question. Give one possible reason why this restaurant has so many windows. Well, geez, I don't know. So on the memo, there's a whole bunch of different things that they would accept, but some of the more common ones would be things like, let me just write it over here. It's for ventilation, get fresh air. Another one is to let in natural light. Okay? Instead of them having to put so many lights on in the shop or in the restaurant, you can use less of that because of the natural light that shines in through the windows. Okay? And then another one is for customers to have a nice view. For customers to have a nice view. So maybe on the outside here, there's like a beautiful lake or something, and while the people are sitting and eating and drinking and doing whatever they're doing, they can look out the windows because there's just so many windows, and they can look at the lake, for example. Okay, well, I guess you wouldn't put the lake here because there's no windows over here. So that's a bit awkward that I mentioned that, hey? But here, for example, are windows. Okay, how do I know that those are windows? If you look at the key, the small windows are like that, and the medium windows are like that. So these would be medium windows, and then there's a small window over here, small window. There's actually a lot of windows, a lot of small windows. There's a medium window. Okay, so yeah, they really do have a lot of windows. Okay, so this next one, this question over here says, calculate the maximum number of chairs available for customers. Okay, so now there are couches that they've told us about, but technically on the key they've called that a chair. So there's a chair and then there's a couch. Okay, and they said how many chairs are there. So let's not count the couches. So here's 4. You see, someone can sit there, there, and there. So that's 4, 8, 12, 16, 20, 24, 28. Now these ones only have 3, okay? So that's going to be 31, 34, 37, 40, 43, and then these ones are all singular. So that would be 44, 45, 46, 47, 48, 49. Oh, here's more. Chairs for days, 51, because that's 49 plus 2, which is 51. And then that's 51. And then here's the huge family with 6. That's going to be 57 chairs. Chairs in total. So it looks like 57. Okay, but now you would have to go write that all out in an exam or test. So you'd say like 4 plus 4 plus 4. You get the idea, right? You'd have to go write that all out, and then you would say equals 57. Okay. Now, with this question, it says, determine the number of seats that are directly facing the wall on the south side. So they add a little note here that says the main entrance doors, which is over here, it's the entrance and exit, are on the south side of the building. So this is the south side. That makes this the north. Okay? So it says, determine the number of seats that are directly facing the wall on the south side. So here's the wall. So how many, determine the number of seats that are directly facing that. So that would be all the chairs that face towards that direction, okay? So that would be people who sit there, 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 and there. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that's the answer. 13 chairs which are facing the south side. Okay, so this question says, give one reason why the restaurant has couches. Okay, so if you've ever gone out to a restaurant, which I'm sure most of you have, but maybe there are some of you that haven't. I mean, I didn't go out to restaurants all that often, to be honest. I enjoy my home-cooked meals, but if you sometimes get to a restaurant, sometimes the restaurant's full, so they ask you to please wait. So I think what's nice with some restaurants is that instead of making you stand awkwardly at the front door while watching people finish their dessert and making awkward eye contact, instead it's better to just chill on the couch. You know, it's more casual. So yeah, so I would say that's probably one of the main reasons, is that it's a nice place to allow your customers to wait while the other guests are finishing their food so that you can have a table. So you could say here, for people who are waiting to be seated. Okay, and there's a whole bunch of other things. Obviously, I have to scan the memo just to make sure I'm including all the different types of answers, but there's some really, like, ones I didn't even think about. Like, okay, so one of them was for people who are waiting to be seated. It's also for people who would like to take photos. So, for people who would like to take photos. It's also for people who would like to wait while, maybe they're doing takeaways. So they're not going to the restaurant, but they're just going out for takeaways. So they're just sitting there to wait for their takeaways. Okay, so we can add that one. Waiting for takeaways. The memo also said for people who are maybe waiting for a lift. Okay, so for people, I just find it funny, like, they're not leaving any possibility out here. They're adding all the possibilities. For people who, I mean, if they want to add all the possibilities, we could really get, like, technical. Could be for people who maybe were enjoying their food at one of the tables, and maybe they have a headache, and they'll just like to go have a little bit of a lie down. Then I guess they could also go lie down on the couch. You know, okay, that was just, don't include that one. I mean, maybe they'll accept it, but yeah, it's not an official answer. So for people who are waiting for a lift. All right, so there we go. And then, I thought of another one. It could also be for people who would maybe like to try out sitting on the couch and then ordering a potato, because, you know, you call that a couch potato. Wow, that was really bad. Wow, even I'm feeling awkward just sitting here by myself mentioning that joke or saying that joke. Okay, I apologize. Okay, let's move. So here's the next question. So it says a person at table number 18. Okay, where's table 18? Ooh, it's part of the big family. Maybe they're having a big argument and this person just needs to go get some fresh air, or they need to go sit on the couch. Okay, so a person at table 18 leaves her seat and walks towards her friend at table number 4. So table number 4 is over here. Okay. She uses the arrow path shown on the seating plan. Oh, okay, yeah. So gets up there, walks down there, walks, and then goes to number 4. Use compass directions to describe her path from table 18 to table 4. Okay. So subject 18 stands up one evening and heads in A, well, let's quickly get our compass. So we know that that's north, west, south, east. So subject 18 stands up one evening and heads in a easterly direction. Okay, use compass to direction. So we would say she goes east. Then takes a 90-degree turn to the right and goes south. And heads on south, making eye contact with somebody sitting at table number 7. And they keep going, and then gets over there and heads in a easterly direction, and then goes to a friend who is sitting alone one evening while looking outside the beautiful windows, because this restaurant just has so many windows, and says hello. Alright, now this question says Norma claims that there are less than 21 tables for customers in this restaurant. State with a reason whether her claim is valid. Okay, so at a first glance you would say she's wrong because there are 21 tables, but let's count and see that all the numbers have been added correctly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ah, Norma, you smarty pants. There's no number 13. And Norma was obviously sitting one evening at the restaurant and decided to check this out, check if the manager's possibly being a little sneaky. Okay, so, man, I'm in a silly mood. Okay, so there's no table number 13. Can you see that? So, her claim is valid. We can say that there is no table 13. Let's just check if there's any others missing. So 14, seeing as we cannot trust this manager of this restaurant anymore. 14, 15, 16, 17, 18, 19, 20, 21. Okay, so there is no table 13. This means there are less than 21 tables. So Norma, little detective, is Norma's claim is valid. There we go. Alright, so with this question, I want to just let you know that the questions do carry on. Okay, so this is the first question. Then it carries on to a second one, another one, and a last one. Okay, so Annexure B, which is this over here, shows the choices on the menu for a function at a restaurant. Customers can choose one protein, okay? So here's the protein choice, and that could either be a chicken, beef, or fish, which would obviously be over there, okay? It's not very vegan friendly now, is it? Okay, now it could be one side order. So you see, your first choice is either you choose chicken, beef, or fish, which is going to go there. Then you move on to your next option, which is your side order, which could either be vegetables or a salad, okay? And then you have a dessert. So, for example, you are a person, you could choose a chicken for your protein, vegetables for your side order. So that would go chicken, vegetables. Sorry. Should actually have another little thing over here like that, for example. But it doesn't really matter. So let's say you chose chicken. Okay, you chose chicken. So you start here. Then let's say you chose, for example, a salad. So then you would go that way. Then when you get to salad, after you've had that and your chicken, you can decide if you would like to have ice cream or malva pudding. So you could go, let's say you go, I love malva pudding. So let's say malva pudding. So then your pathway would go like that. So you would go there, there, there. Or maybe you are someone who just wants a piece of beef. So you start here. Okay, and then you like vegetables, so you would go that way, and then you love ice cream, so you would go that way. Okay, and I'll do one more example before we actually start going to the questions and stuff. Sorry, I sometimes like to do this just so we get a good idea. Let's say you love beef, you love your salad, and you love a malva pudding. Then you would go beef, you would start there, you would go salad, and then you would go malva pudding. Okay, and that would be called BSM because it's BSM. Okay, got the idea of how this little diagram works. So let's go read the questions now. It says name the type of diagram. Now, this type of diagram where they branch out like that, it's called a tree diagram. Okay, now with this question, it says write down the missing outcome of 2.2.2a, so that's over here, and the protein choice at 2.2.2b. Okay, so let's look at 2.2.2a. So these letters over here, they just tell us what the person did. So for example, if you start here chicken and you go up to vegetables and then you love your ice cream, then look at your path. CVI. Or maybe you went chicken, salad, and I over there. So that would be CSI. So that's CSI. So, see, if you take the top path, that goes there. If you take that path, that goes there. If you take that path, that goes there. And then if you take, let me do this in a different color. If you take that path, that would go there. So that would be CSM. Okay, 2.2.2b. So remember the protein choices. They told us that there's chicken, beef, or fish. So we can see the chicken, we can see the beef, and so this one would have to be fish. This question says, state the number of combinations that use beef. Well, have a look here. This one doesn't use beef. 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 So you would have to look here. They all have a B, and the B is for beef. So how many combinations use that? Well, that's going to be 4 different combinations. Then this question says, determine as a percentage the probability of choosing a meal that has malva pudding as the dessert. So what we can do is we can actually just look at all of these over here. This is one way to do it. There's actually easier ways of doing it, but I'm going to show you all the different options. So let's say we looked at this, right? So out of all of those options, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So out of the 12 different options, how many have malva pudding? Well, there's 1. This one would have been a malva pudding over there because that one was CSM. So that's 2, 3, 4, 5, 6. 6 out of 12. If you multiply that by 100, because we would like it as a percentage, that would be 50%. Your other option is the following. Everyone's going to eat dessert, okay? We're just assuming that everyone's going to eat dessert. When you choose a dessert, how many dessert options are there? There is only 2 options that you could choose from. So the chances that you would choose malva pudding would be 1 out of 2. And if you multiply that by 100, you're also going to get 50%. So whether you chose the first option I did, or whether you chose this way that I just showed you now, it doesn't really matter. You're going to get 50%. So with this question, remember that the questions do carry on. So this is going to be first question, second question, and then we've got a third one over there, and then a fourth question. Okay, so stick around and have a look at all of these questions. So it says here, below is a simplified route map of the Los Angeles Marathon, the LAM, in the United States of America. The LAM route is 26,2 miles. Okay, and then it just shows us everything that's happening here. So you start the race over here, and you go this way, 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 boom, there, and you go to the finish. Okay, pretty straightforward. Now, it says explain the meaning of the route map. So a route map is a map showing the route that learners need to follow in the race. Okay, then the next question. Describe what is meant by map not to scale. So what it means pretty much is that you shouldn't, for example, take a ruler and then measure this length on your map and then somehow think that you can go calculate the real life distance. Because this map was not drawn according to a specific scale. So maybe they made this road very short, whereas in real life it's the same length as this one. They didn't draw it according to a scale. They just did like a rough sketch. So we can say that there is no relationship, or let's rather say ratio, between the map length and real life length. Okay. So this next question says, the runners in the Los Angeles Marathon have to pass underneath a bridge at a certain point during the marathon. Okay? Explain how this is indicated on the route map. Well, you see it's this area here, so where they start, they go under a bridge there, and then over here, you can see that the arrow, this arrow, which you see over there, they don't show it over there. There's a gap, and then it does, and then over here again, you see there's no line over here. They're doing this. So for example, there's a road, and then there's a road, and there's a road, and then what happens is that they draw like an arrow, and then they draw it like that. They don't draw it over. So what we can say is that there is a break in the line showing the route. Okay, so for example, once again there, and then there's a road. Okay, and then this arrow, they stop drawing it, and then they just draw it on the other side. Okay, so there's a break in the arrow. This question says, write down the number of times that a runner who completes the marathon will pass underneath a bridge. So this part in the beginning here is quite confusing. It's like, it looks like there's a bridge there, but then they've got this big black like arrow, and I think what they're trying to show us there is that they're going over that part. Okay, so that's not going to be a bridge. Then what happens is the people go this way, this way, this way. They go under a bridge once, then they go under a bridge again, so that's 2 times already. They go this way, there's no bridge, no bridge, no bridge. Oh, there's another bridge, that's 3, no bridge. This is not a bridge because they're going over the bridge. See that? Oh, here they're going under a bridge again, and then back to the finish. So it looks like that was 4 times. Okay, so the answer is 4. Okay, this question says, write down the general direction in which the runners will face when they start in Flower Street. So this is north at the top here. So that's north, then that's south, that's east, and that's west. So here they are standing when they're about to start the race in Flower Street, okay? So, I mean, if they were facing that way, that would be south. They're almost facing that way. So I would say like southwest. Yeah, southwest is the answer. Okay? Because you see here they're standing. They would be standing in this direction, facing that way. So south would be there. West would be there. So it's in between the two. So it would be southwest. This question consists of 3 questions. So we've got this one over here, this one over here, and then we'll finish it with that one over there. So every learner in a technology class is expected to have press stick and Prit. The press stick is packed in a rectangular shaped sleeve, and the Prit in a cylindrical container. Okay, so here's press stick, and here is Prit. Okay? And they give us the different dimensions, like the length, the width, diameter, height, all of those types of things. Okay? So the first question says, calculate the perimeter of the front of the press stick sleeve. You may use the formula 2 multiplied by length plus width. Okay, so if they give you a formula to use, just follow it like that. So we know that the perimeter is equal to 2 multiplied, and then length is 239, And then what is the width is 89. You see, we're literally just going to plug it in. Then you're going to go calculate it just like that on your calculator. So you just go type it in exactly like that. And that should give us 656. And that is measured in millimeters. So we can just change it to millimeters. We're not going to put a 2 over here because that's only for area. And we're not going to put a 3 because that's only for volume. Here we're just measuring perimeter, which is what we're actually doing here, by the way, is we're just measuring the distance all the way around. Okay? So we're just saying this number plus this number plus this number, which would be the same as 89, plus this number, which would be 239. Okay, so yeah, but this formula does all of that for you because it takes the 239 and it takes the 89 and then it also multiplies by 2. What that multiplying by 2 is doing is it's telling us that there's another 239 over here and there's another 89 over there. Okay, so that's correct, all done. So you don't have to use this, just another thing, sorry, you don't have to use this formula that they give you. You could definitely also just say like 89 plus 239 plus 89 plus 239. And you could go add that all up and you will get the exact same answer of 656 millimeters. So with this question it says calculate, but now it says in centimeters. But this, okay, wait. Calculate in centimeters the height of the opening and closing part of the prit. So that's this part over here. Okay, so what we can do is we can realize that the total height from the very top to the very bottom is 114 millimeters. Okay, so that total height is 114 millimeters, but they want the answer they want us to use centimeters. So remember that in 1 centimeter, there are 10 millimeters, okay? So you see that the millimeter number is always bigger than the centimeter number. So here we have a millimeter number, and we need to change it to a centimeter number. So we're going to divide. We're not going to multiply, because then this number will become even larger, okay? So we're going to say 114 divided by 10, and that's going to give us 11,4 centimeters. So that is this total height of the glue stick. Okay, that's not our answer. Now, we know that this part is 2.5, and we know that this part is 7. So if you look on this side, and if you look on this side, then we can use that information to help us work out this part over here. Because we know that this entire length from top to bottom is 11.4 centimeters. Okay? Because it's obviously the same as on this side. So if you look at this, this is already 2.5 and this is already 7. So if we add that together, that's 9,5. So how much more do we still need to be able to make 11,4? Well, we can then say 11,4 take away 9,5. And that would give us 1.9 centimeters. So that part there would be 1.9 centimeters. This one says that the actual height, and by the way, I left out the glue stick in this question because we don't actually need it for this question, okay? So the actual height of the glue in the Prit container is 8.5. And the volume of the glue is 52,346. Show how the volume of the glue was calculated if the diameter of the glue is 28. So you may use this formula. Okay, so something they said here, they said show how the volume was calculated. And they told us that the volume is this one over here. And it's measured in centimeters. Okay, so we need to make sure all of our measurements are in centimeters. Okay, so the volume is equal to 3,142. I'm using this formula over here, multiplied by radius. Now remember, when you have a circle, the radius, or let's say the long one that goes all the way across, that is called the diameter. And then the one that just goes up to there, well, that's your radius. Okay, so radius is half diameter. The radius is half of the diameter. So, okay, so they give us the diameter over here. So we need to first convert that into centimeters, because that's in millimeters. So the diameter is 28 millimeters. So to get that into centimeters, remember that 1 centimeter is 10 millimeter. So you see how the millimeter number is larger? It's 10 versus 1. So we need to change this number to centimeters. The number is going to become smaller, so you're going to divide by 10. You're going to divide by 10, which would give you 2.8 centimeters. Okay, but remember that 2.8 centimeters, that's the diameter. So to get the radius, you're going to half that. So 2.8 divided by 2, which is 1.4. And so here you can say 1.4 to the power of 2 multiplied by the height, which was given as 8.5, and that's already in centimeters. There we go. And then we can go work it out. And we should get 52,346 if you do round to 3 decimal places. And that's exactly what they have over there. Moving on to this part, it says determine, rounded to the nearest gram, the mass of the glue in the Prit container if the density is 0.82 grams per centimeter cube. It says that you may use this formula over here. Okay, so we're going to use their formula. So we know that density is equal to mass divided by volume. So you could say that as, we could say density equals to mass over volume. That's another way of writing it if you want. So let's just go fill everything in. They say that the density is 0.82. So we go fill that in over there in the place of density. What are we looking for? We're looking for determine the mass. Okay, so we don't know what the mass is. The volume we did already know from there. So that's 52.346. Now, some learners are not comfortable with these types of scenarios. Like, how do we get this by itself now? So let me try to explain. So what our goal for this question is our goal is to try and get the m, or the mass, alone, because that's what you're trying to calculate. So you need to take this and you need to somehow take it to the other side. And the way that you can do that, you have 4 different options. You could use, now not all of these are correct, but I'm just saying that there is plus, minus, times, and divide. Those are the 4 basic ways to move something from one side to the other. But only one of those is correct. It's not going to be plus and minus, because that you only do if your question was more like this. Maybe you have something like that, for example. Then you can move the 52 over by using, either plus or minus. Okay, so it's either going to be times or divide. So what I would ask you to do is, and some learners are really good at this, some struggle quite a bit, so I'm going to try to explain it as best as possible. So in mathematics, when you move things from one side to the other, you always have to use the opposite when moving. So you always have to use the opposite of what's happening already. So for example, if you have 5 equals to, or let's say you have x plus 3 equals to 7, then what is happening, like what is in front of this 3 at the moment? It's a plus. So when you move it to the other side, you change it to a minus. And so you would end up doing something like that. Okay, so you see how the plus became a minus. Now, what are these 2 things doing over here right now? Are they multiplying or are they dividing? Well, this line over here tells us that they are dividing. So what is the opposite of divide? It's multiply. So when you take this to the other side, it becomes a multiply and not a divide. So it's going to end up becoming 0.82 multiplied by 52.346 equals to m. And if you had to then go work out m, which is the mass, you end up with 42.92 grams. But then they did say rounded to the nearest gram. So that would round up to 43. So the final answer would be 43 grams. So for this question, we will be doing one question over here and then another one over here. So they tell us that water is a scarce resource in South Africa. Do you guys remember, just by the way, I can't remember exactly what year it was. I think it was maybe 2017 where South Africa had a water shortage. I don't know if some of you can remember that, but yeah, I remember I got pretty stressed about it. I remember the one night, it was quite late at night, and I went to my office, which was in my house, but I have like a big whiteboard, and I was trying to design like, because at one point they were saying that we were going to have to queue up for water, and you were going to be allowed to take like a 5-liter water container. So that night I was busy like designing how I could like use like a pole, and I could slide like 5 or 6 5-liter water canisters onto the pole, and then I could carry it like that. And then I was trying to calculate whether I'd be strong enough to carry all of it. And I was really thinking about like, how can I get as much water as possible? And yeah, I remember that. I didn't like it. It was, things like that, that, when I remember they, ration down the water to like 50 liters per person or something, and that was like it was quite crazy. So yeah, I wonder if you guys could remember that time. It was really, really, really interesting here in South Africa. All right, so water is a scarce resource in South Africa. The graph below shows how the volume of water in a toilet cistern has been reduced over the years. The picture next to the graph shows a toilet pan with a toilet cistern. Okay, so the toilet cistern is that, when you're in the toilet and there's that big box behind you, that's the toilet cistern that they're talking about. And what they're trying to tell us here is that back in the days, when our grandparents and parents were sitting on the toilet, they had 7 gallons that they could use to flush away all their business. And then in 1982, it became a little bit less. And after 1996, wow, look at that. After 1996, we only use 1.6 gallons. And look at this. Back in the day, those homies were using like 4 times as much water as we do to flush their toilet. Or to flush the toilet. That's crazy. Those guys were not messing around at all. Okay, so now they tell us that 1 gallon. A gallon is like a unit of measurement for liquids that they typically use in the United States, for example. But to convert it to liters, it's like that. Okay, so it says calculate in liters the volume of water used during February 2022 by a family of 5 if each person flushed the toilet an average of 4 times a day during the month. Okay, so you can do this however you want. There's not however you want, but there's many ways you could do this. But I'm going to just look at one person in the family. So let's just look at one person. Okay, now they're going to use the toilet 4 times a day. Well, they're going to flush the toilet 4 times a day. Okay, so that's going to be 4 flushes, and each flush is going to be, remember that the year 2022 is going to be this one, because it says 1996 onwards. So we're going to multiply that by 1.6, okay, now, and that will be how many gallons, because remember that's still measured in gallons, so that's going to be 6.4 gallons per day. Gallons per day. Okay? That's what one person is going to use. 6.4 gallons per day. Now, in February, let's forget about leap years and all of that nonsense. Let's just say that there's 28 days in February. Okay, so 28 days in February. So if this person uses 6.4 gallons per day, then how many gallons would they use per month? Well, that would be 6.4 multiplied by 28, because it's 28 days in February. And so that'll be 179.2 gallons per month, or at least in February. That's for one person. Now, how many people are there in this family? There are 5 people. So we're then going to take that amount, and we're going to multiply it by 5. and that's going to give us 896 gallons for that month, per month. Okay, so that's how many gallons they used in February. Let's rather say in Feb. Now, they would like us to convert it to liters. So 1 gallon is the equivalent of 3.785 liters. So all that we need to do now is just say 896 multiplied by 3.785, and that would give us 3,391.36 liters used in Feb. This question says, state one way in which a person can save water. Okay, so one way that I've heard of people to save water is the following. So you've got this cistern, right? Now let me quickly explain how it all works. So here you've got your cistern. I'm going to show like a side view. And when you go to the okay, now that cistern has a certain level of water, and that level of water is very accurate. It's got something inside that can measure the level of water and make sure that it's perfect. Now, when you flush the toilet, that water goes all the way down. Okay, like it empties out completely. And then what happens is after you flush, you can hear that like noise after you flush. And that is the water that is busy entering here again through the pipes, okay? And it's busy filling up until it gets to the top again. So, and once it gets to the top, there's like there's some type of instrument that can measure when the water has reached the right level, and then it stops filling up water. Okay, so one way that we could do this is what some people do is you take like a brick. You literally go take a brick and you just put it in the bottom of the cistern like that. Now, you might be wondering, Kevin, how does that help? Well, let me explain. That brick takes up volume, okay? So what happens is that the water now starts filling up over there, and over there, and over there, and over there, and over there. And once it gets to this level, the water stops flowing in. So it's not about how much water comes in, it's about when it reaches the maximum level, then the water stops flowing in. So you see how by putting the brick there, we've used less water, because this area, or this part over here, used to be water as well. But now, instead, we've just got it as a brick. Okay, obviously you can't go fill up the whole cistern with bricks, because then you're not going to flush down your your business. So maybe 1 brick will be okay, maybe 2 bricks, but you might run into problems if you just use too many bricks, because then you're not going to have enough water, because what does the water do? The water helps wash down the stuff. So you got to maybe use 1 brick and then it should be okay. So that was actually one of the answers in the memo is you could put a brick in the cistern. Okay, some of the more clean methods would be to upgrade to a better model. Upgrade to a better model. A model that's more... Maybe a model that's a little bit more better designed, so you don't need as much water like our grandparents were using back in the day. I still can't believe how much water they were using. That's literally like sitting at the toilet and then you have like a JoJo tank behind you. Imagine that's how much water we needed to use, like to go to the toilet. Like we had to use a JoJo tank. Those big like rain water collection tanks that people have in their gardens. Imagine that was like attached to your toilet and every time you flush that whole thing has to empty. Okay, maybe I find it more funny than most people would find it, but okay, yeah, so so that's one way you can upgrade to a better model. Okay, so with this question we're going to do this question over here, and then this one over here, and this one over here. Okay, so Oma intends baking 2 milk tarts for her friends who will be arriving at 5:30. She uses the ingredients and information below. She can only bake 1 milk tart at a time. While the first milk tart is in the oven, she prepares the second milk tart. Clever. She's using her time wisely. In order to put it in the oven at the moment that the first one is taken out. Okay. So she's efficient, like some grandmothers would be chilling on TikTok while the first one's baking. But this grandmother, she realizes, while the first one is in the oven, I can prepare the second one. So as soon as the first one comes out the oven, I can put the other one into the oven. Okay, so let's see what they have here. So they've got preparation time, cooking time, and it serves 8 people. Jeez, okay, they're not messing around. So it says here, Oma would like and then it says here 1 cup is equal to 250 mils in case we need that. So it says here, Oma would like the second milk tart to be taken out of the oven 15 minutes before her friends arrive. Determine the time that Oma must place the first milk tart in the oven. Okay, so we have a mission, guys. The friends arrive at 17:30. Okay, so that's when the friends arrive. So Oma would like the second milk tart to be taken out of the oven 15 minutes before her friends arrive. So the second milk tart, let's be more specific here. Let's say 17:15. So 15 minutes before that, the second milk tart, I'm just going to say the second tart, must be finished. Must be taken out oven. Taken out oven. Okay, cool. Let's see. So what we can do now is we know that the cooking time is 40 minutes. Okay, so if we go 40 minutes before that, that'll take us to 16:35. You might just want to verify that with me. I'm just going to verify it as well. 16:35 plus 25 minutes would be 5 o'clock plus 50. Yeah. Okay, so what would have happened over there? That would have been, so we know that from 16:35 up to 17:15, that is the second milk tart is busy cooking. Second milk tart is cooking. Okay, now you might want to say, okay, Kevin, now I'm just going to minus 30 minutes, but be careful. What they told us was that while the first milk tart was in the oven, she was busy preparing the second one. So the second one, the second milk tart's preparation time was happening at the same time that the first milk tart was in the oven. So she saved a bit of time by doing that. So what happened immediately at 16:35? Well, that is when she would have taken the first milk tart out of the oven and put the second milk tart into the oven. So what we can do now is we can look at 16:35 and we can take away another 40 minutes, which was the time that the first milk tart would have cooked. Okay, so if we minus 40 minutes, that would take us to 3:55. Okay, so from 3:55 up to 16:35, that's when the first milk tart is cooking. Okay, so and then remember, while the first milk tart was cooking, she wasn't just standing there and chilling on TikTok or looking at her Instagram reels. She was busy preparing the second one. So that's why we don't have to worry about this time, because she was doing it while the first milk tart was cooking. So we don't have to add any time there because she was saving time. Okay, so it says here, determine the time that Oma must place the first milk tart in the oven. Determine the time that Oma must place the first milk tart in the oven. So that would be at 15:55. Let me draw this on a little timeline for you, and I'll show you that it all works out. So at 15:55, she puts the first milk tart in the oven. So I'm just going to say first tart again, in the oven. Okay? And then how long does that go for? That goes for 40 minutes. Okay, 40 minutes. That's how long that one cooks for, or bakes for. Or no, cooking. Okay, whatever. Look, I'm not someone who's like, I love cooking, like supper and stuff, but I'm not that into baking and all of that stuff. So yeah, whether I call it baking, cooking, I'm sorry. Okay, so the next one is, okay, so that would have been done at 16:35. Now immediately, she can put the second milk tart into the oven because she already prepared the second one so during this time, somewhere over here, she took 30 minutes. Okay, and let me just write this better. So somewhere in between here, she took 30 minutes to prepare the second one. 30 minutes to prepare number 2. Milk tart number 2. Okay, so that 30 minutes is not, we don't have to add that on to her time because she was clever. She did it while the first one was cooking. Then 1635, she, what she does here is she takes, well, let's say that milk tart number 1 is now finished, and then number 2 begins the cooking. So then she'll cook for another 40 minutes, and that'll take us to 1715. And that's perfect because she wanted the milk tarts to be complete 15 minutes before her friends arrive, which is at 17:30. So she should determine the time Oma must place the first milk tart in the oven. She should do it at 15:55. So I know that I wrote this all out in a very informal way. So on the memo, what you could do, or not on the memo, but in the test, what you would do is you could say 17:15, and then you could just minus the 40 minutes minus in fact, you would start at the 17:30 and you would take away 15 minutes, and then you would take away 40 minutes, and then you would take away 40 minutes again, and you would arrive at this time of 15:55. So here's the next part. It says convert the baking temperature to degrees Celsius. Okay, because here we've got the baking temperature, but it's in Fahrenheit. So they want us to convert the baking temperature to degrees, rounded to the nearest 10 degrees, and you can use the following formula. Okay, so it says that C, or Celsius, is equal to Fahrenheit minus 32 multiplied by 5/9. So you're just going to put the Fahrenheit temperature in over there, and then just go type it on the calculator, just like that. So wherever you see a bracket, put a bracket. And that's going to be 162,77 degrees Celsius, okay? But they said round it to the nearest 10 degrees. So you could either go to 160 or 170. Which one is correct? Which one is closer to this number? Well, that would be the 160. So the Celsius temperature is going to be 160 degrees Celsius. Okay, this question says determine. I don't know what happened there, guys. Wow. Okay, determine. What is going on? Determine how many liters of milk Oma needs to bake the 2 milk tarts. Okay, so how much milk does she need in order to bake 2 milk tarts? All right. Okay, so determine how many liters of milk Oma would need to bake 2 milk tarts. Now here it says for 1 milk tart. Okay, so how many cups of milk do we need to use for 1 milk tart? 4 1/4. Okay, so we're going to definitely have to multiply that by 2 because we're baking 2 milk tarts. Okay, and if we work that out now, Casio calculator users, listen up. There is a glitch on the Casio calculator where if you type 4 and then you just type 1/4 next to it and you type that on your calculator, if you've done this incorrectly, it's going to tell you that the answer is 1. So the way that you have to do this is you have to say, if you want to write it like that, you're going to say shift, and then you're going to push the button that does like a top part and a bottom part. And if you do that correctly, it should open up 3 parts. There, and there. That is how you need to fill in this number. Okay? You don't want to just go write a 4 and then just push space and then try open up something next to it. That doesn't work. It's a bit of a glitch on their system. I know what's happening there, but yeah, I wish they fixed it, but okay. I'll try and give them a call sometime and just be like, yo, what's up, Casio? No, I'm joking. Like, I'm not going to try phone. I don't even know their contact details. And yeah, it's just going to be awkward, like trying to tell one of the salespeople, like, hey, would you mind changing your whole calculator? Okay, so let's move on. So you're going to type it in the correct way, and you're going to multiply that by 2. And that's going to give you 8.5 cups. Okay, that's not liters, that's cups. So that's how many cups we need. Then it says that 1 cup is 250 mils. So we could then say that 8.5 multiplied by 250. And that's going to give us 2,125 mils. But now they said how many liters. So remember that in 1 liter, there is 1,000 mils. So we need to change that back to liters now. So you would say 2,125 divided by 1,000, and that's going to give us 2,125 liters. In this question, we are going to be looking at one question over here, another one. Who sings that again? It's DJ Khaled. Okay, so let's quickly go back. So there's going to be all of those questions, okay? So let's start. It says that Itumeleng makes and sells birdhouses at a local flea market. Annexure C, which is this one over here, shows the diagram of the parts and the assembly instructions. He uses a single board that is 14 centimeters wide. Okay, so he uses a single board that is 14 centimeters wide and 20 millimeters thick to make one birdhouse. Use the information above and Annexure C to answer the questions that follow. So the first question for 3 marks says, show that the length of the board needed for a single birdhouse is 1,500 millimeters. Okay, because in this part here, they tell us how wide his piece of board is, okay? So let's say he uses a board like this. They tell us how wide it is, 14 centimeters, and that makes sense because for all of these parts on the birdhouse, all of their widths are 14. Can you see that? All of the widths are 14, so that makes sense why he uses a 14 centimeter wide. And then the thickness of the wood thickness, so like this part here, this thickness is 20 millimeters. Okay, and that's where we're using it there. So that would be the wood thickness, those parts. Okay, but no one told us how much wood he uses. Like, how high does this go? Like, like when he goes to the shops, like, I don't know, Builder's Warehouse or wherever he buys his wood, how much does he need? They've only told us how wide it is and how thick it is. Okay, so let's see. Now, I'll be honest. So we obviously have to work out the total length of plank. For example, as I showed you now, they've given us the width and the thickness, but they didn't give us the length. And so I went and showed you here that maybe, you know, there's all these different parts that you would cut off. But then I realized that they're showing us over here what it looks like. So he goes to the shops and he buys a piece of plank like that, okay? And then he cuts the roof part. So you got to be careful. Check this out. The roof part is 19 centimeters. The front is 23. The floor is 10. The side, now look here, this is the long side for side 1, which would be 25. But then you only have the short side of side 2, which would be 23. Whereas I was just going to go cut 25 and then another 25. But because of the way that they, you know, it's all one part over here. If you think about it carefully, you don't need to cut a 25 and a 25. You actually just need a 25 and then a 23. And then if you had to measure it on this side over here, it would then be a 23 and a 25. But it's still the same amount of wood that you need. Okay, so this part caught me out earlier when I tried this the first time. And maybe you looked at it as well and you were like, yeah, I would have just cut side 1, and then I would have just cut side 2. But it's a little bit of a sneaky thing. If you think about it carefully, you don't need to do it like that. You could just cut it at 25 and then 23. And then the back part would be 41. Okay. So you could then say 19 plus 23 plus 10 plus 25 plus 23 plus 41. And if you add that up, you get 141, and that's in centimeters. Okay. So it says, but show that it would be, show rounded to the nearest hundred that the length would be 1,500. So, and that's in millimeters. So remember that in 1 centimeter, that is the same as 10 millimeters. So what we can then do is we can say 141 multiplied by 10, and that's going to be 1,410 millimeters. Okay, now when they say to the nearest 100, you don't want to just round this down to 1,400, because remember, this is a piece of wood that you need to make something. So if you rounded it down, you wouldn't have enough wood. So what they actually mean is like rounded upwards to the nearest 100, and so that's where they're getting the 1,500. So if Intumaleng had to go to the shop, he would ask them for a 1,500 millimeter piece, because they probably sell it in 1,500 millimeter pieces, and then he can just, they can cut it for him, or he can cut it. But yeah, so that's how they got the 1,500 millimeters. Okay, so for this next question, it says that Intumaleng stated that in step 2, the 10 centimeter side, so that's this side over here, will go against the back. Verify showing calculations whether his statement is correct. So in step 2 here, what they first told us to do is they said nail the longest side of side 1 and side 2 to the back. So what they mean by that is, okay, so here we have the back. Okay. Which is there. Then they said take the longest side of side 1 and side 2, and then nail that to the back. So that would be, and remember that this one is 41 centimeters, but these are only 25 centimeters, so it'll only go up to about there. Okay, so what they're doing is they're saying nail it to the back like that. Just like we can see in the picture here. You see, so there's the back. And then they're nailing that piece there and there. Okay, so I hope you can visualize that. So these two parts here are coming out of the screen right now. You can imagine that they're coming out of the screen. Okay, so I tried to do like a little drawing over here. So you've got the back, and then you've got your first side piece, and then your second side piece would sort of come out like that. So maybe something like that, okay? So I hope that makes sense. So, okay, so that's what we've got there. Now, what he's saying is that in step 2, he's going to position the floor they said that we must position the floor between the two sides. So we're going to go take the floor now, and they're saying that we should put it over here. Okay, but now what we don't know we don't know whether we need to put the floor in this orientation or whether we need to turn it so that it's longer like that. So the way that I'll show this to you is that we know that the floor, we know that this total length from the outside to the outside is 14 centimeters. Now we know that these thicknesses, remember these thicknesses over here are 20 millimeters. So if you change 20 millimeters to centimeters, remember that there's 10 millimeters for 1 centimeter, then what you would find is that this is 2 centimeters. So if you have 2 centimeters over here, and then another 2 centimeters over here, then how many centimeters do you still have in the middle here? Well done if you realize that would be 10. There would only be 10 centimeters left over, because 14 is the total, and then minus 2, then this part here would only be 10 centimeters. So he is correct in saying that it's the 10 centimeter side that will go against the back. Okay, so he's going to put the 10 centimeter side against the back, not the 14 centimeter. So how would you actually get your marks here? Well, you could say 14 centimeter, take away the 20 millimeters, or you could first show that 20 millimeters is 2 centimeters. So you could say minus 2 centimeters, minus 2 centimeters, which is equal to 10 centimeters. So we could then say he is correct. Okay, this one says that the front part of the birdhouse has a circular hole with a diameter of 4.2 centimeters. Calculate in centimeters squared the exposed surface area of the front part of the birdhouse. Now remember, here they've called the front, it's literally just that block there. There. Okay. So let's pretend that it was just a rectangle. Let's say there was no circle. It was just one big rectangle. Okay, so like that. What would the area be? So we could say area of the rectangle, and they've given us the formula length times width. So that would be 23 multiplied by 14. So 23 multiplied by 14. So we're forgetting about the circle. Okay, we're just saying 23 times 14, and that's 322 centimeters. Now, because it's area, we say centimeters squared. Let me write that a bit better. 322 centimeters squared. Okay, so that's the area of that front part. Now we can go work out the area of that circle. So area of the circle. So we can use the formula 3,142 multiplied by the radius squared. But we don't have the radius, we have the diameter. So remember that a radius is half of a diameter. So the radius is going to be a half of 4.2, which is 2.1 centimeters. So the area of that circle would then be 3.142 multiplied by 2.1 to the power of 2. And if you had to work that out, I'm not going to round off right now, so you're going to get 13.85622. Okay, centimeters squared. Now, think about this. We said that this entire area was 322. But the circle is actually empty space. It's empty. But we have already counted the circle in. We included all of that when we said 322. But this is actually empty space over here. There's nothing there. So we need to minus that, or we need to take that away from the 322 to see how much area we actually have over there. Okay? So what we can then do is just say 322 take away 13,85622. And that's going to give you 308.14 centimeters squared. 308.14 centimeters squared. Itumeleng paints the exposed exterior surface of a birdhouse. The total surface area of a birdhouse that will be painted is 0.2888 meters squared. He applies 3 coats of paint according to the spread rate as follows. The first coat, he does it like this, and then the other 2 coats, because remember he's going to do 3 coats in total, so the next 2 coats he does it like that. Itumeleng stated that he would be able to paint 7 of his birdhouses with only 500 mils of paint. Verify showing all calculations whether his statement is correct. Okay, so quite a good question. Right, so let's just say, okay, we don't know what the birdhouse really looks like, but let's just say it's a big board. It's just one big board. That's what the birdhouse is. Okay, obviously it's like some better looking structure. It's like something that birds can actually go in or whatever. But let's just say that that's how much we need to paint. 0.288 meters squared. Okay, that's how much you're going to paint. And we know that he's going to apply 3 coats of paint. So he's going to do a first coat and then a subsequent. Subsequent means the remaining coats. So the first coat he will apply at 10 meters squared per liter, and then he'll do the second coat, which would then be in this one, so that would be 14 meters squared per liter, and then the third coat will be the same. It'll be 14 meters squared per liter. Okay, so let's have a look at this first coat. It's 10 meters squared, and that'll be if you have 1 liter. So what they mean is, with 1 liter of you would use if you have 1 liter of, or no, the better way to think about it is, if you have to paint 10 meters squared, then you would need to use 1 liter of paint. But we don't have 10 meters squared. We have that many meters squared. So we somehow are going to have to try change this to this. So how do we do that? The first thing I would say is, let's change this number to a 1. How could we do that? Well, we could divide by 10. So we're going to divide by 10, but what you do to the one side in maths, you have to do to the other side. So that's going to give us 1 meters squared. And on this side, if you say 1 divided by 10, you're going to end up with 0.1 liters. Okay? Now, if we multiply this by 0.288, and we do the same on this side, then what would this become? Well, that would become 0.2888. And then on this side, if you go type that in on the calculator, okay, now don't round this number off. It's going to be 0.02888 liters. Okay, so what that tells us then is that to be able to paint that first coat, okay, this is how many liters of paint we are going to have to use. Okay, now we are going to go do the same for the second and the third coat. So I'm actually just going to say second and third coat, because it's the same. So they tell us that 14 meters squared, if we have to paint 14 meters squared, we would use 1 liter of paint. But once again, we're not going to be painting 14 meters squared. We're only going to be painting that. So we need to change this meter squared into that meter squared. So we could do that by first dividing both sides by 14, because then that gives us 1 equals to, I'm just going to keep it as 1 over 14 for now. Whatever that gives you, just don't round it off, or you can just leave it as 1 over 14. Then I'm going to multiply both sides by 0.2888, and that'll give us 0.2888 meters squared over here. And on this side, don't round off, it'll give you 361 over 17500. Okay, so what that means is that if you want to paint with the second coat, if you want to paint this amount of area, you're going to use this many liters of paint. But remember, you're going to paint this one twice, because you're going to do a second and a third coat. So how many liters are we going to have to use? So the total liters for one birdhouse is going to be the first coat, where you paint 0.2888 meters squared, and you're going to use that many liters of paint. So 0.0288 plus. Now, when you paint the second coat, you're going to use that many liters of paint. And when you paint the third coat, you're going to do exactly the same. If you go work all of that out, or actually, let's go, let's put a bracket around all of, let's go work that out. I don't want to jump steps. Okay, I'm not going to round off just yet. That's going to give us, because in maths, when you round off, you only want to round off at the end. So 6137 over 87500 liters. Now he says, Ntumaleng says that he would be able to paint 7 birdhouses. So let's see how many liters of paint you would need. So it's going to be 6137 over 87500, and then you would multiply that by 7, because this is for one birdhouse. Okay. All right, and that's going to give us 0.49096 liters. Now he says he would be able to do it with 500 milliliters. So let's change this back to milliliters now. So remember that in 1 liter, it's 1,000 milliliters. So we could then multiply this by 1,000, and that would give us 490.96 milliliters. So to be able to paint 7 birdhouses, Itumeleng would need that many mils of paint. He says he could do it with 500 mil of paint, so he is correct. He will be able to do 7 if he uses 500 mils of paint. So he is correct. Okay, so it says that Itumeleng has the following expenses for a birdhouse business. So they tell us that all of his rentals cost that amount. His transport is 100 Rand per week. And then he buys some wooden boards, paint, sundries. Okay, we'll go through that later. And then it's also got some important information here. It says that he uses a single board to make 1 birdhouse. So he uses a single board to make 1 birdhouse. Okay, that's going to be quite important. Now it says that Annexure D, which I've attached over here, shows the graph representing Itumeleng's weekly income and expenses for his birdhouse business. First question: the equation to calculate his expenses can be written as follows. Okay, first question: show how the value of 350 Rand, which is his fixed weekly cost, was calculated. So if we look at his different costs over here, we can see that they said his fixed weekly cost is 350 Rand. So we can see the per week costs are over here. There's a 250 Rand per week for the flea market and the rental of the store, and then also for transport, they've got that at 100 Rand per week. So if you just simply add those two fixed costs together, his fixed weekly cost, we can see that that would be 350 Rand. So that's where they got that from, which is over there. Okay? The next one, calculate the value of P, which is the variable cost to make 1 birdhouse. Okay, so to make a birdhouse, he needs paint, and that's how much he would use per birdhouse. He needs some sundries, which are like extras and things, which are 10 Rand 70 per birdhouse. He also needs wood. But now, here we got to be careful. Here they tell us that the wood is 287 Rand and 40 cents for a bundle of 6 boards. But here they tell us that he only uses a single board to make 1 birdhouse. So this is the price for 6 boards. Okay, but what we want to work out is what does it cost him to make 1 birdhouse? So we are going to have to divide this number by 6. So to work out the price of 1 board, we're going to say 2870,440 divided by 6, and that's 47 Rand 90. Okay, so that's how much he has to pay for 1 board. Now there's paint, so we're going to say 47 Rand 90 plus his paint, which is 21 Rand 40, plus his sundries, which are 10 Rand 70. So those are the costs to make 1 birdhouse, okay? And if you had to go add all of that together, you end up with 80 Rand. So that's how much you would pay per birdhouse. Alright, so now moving on to this question. It says, explain the break-even point. Now they're not saying just give a definition. They want you to explain it in this context. So according to this business, what does it mean? So what does break-even point mean? It's the point where the income is the same as the expenses. It's this point over here. It's where the person is not making any profit, but they're also not making any loss. The income and the expenses are exactly the same. Okay. So the way that you'd explain in this context, it is the point where the income from selling birdhouses is equal to the expenses of renting, which is this one, transporting the birdhouses, which is this one, and then we can also and making the birdhouse. And that's where you have paint and wood. So making the birdhouse. So it's the point where the income from selling the birdhouses is equal to the expenses of all the renting, transporting, and making the birdhouse. So the next question says, during one of the weeks, Itumeleng made 15 birdhouses. Okay, but he only sold 12. Show by means of calculations if he made a profit or a loss for that week. Okay, so in that week, whether he sells 100 birdhouses or whether he sells 5 birdhouses, he's always going to have to pay his fixed cost. Okay, so his expenses are going to be 350 Rand. That's your fixed cost, remember? Plus, can you remember in the previous question, we see that to make one birdhouse, it's 80 Rand. So how many birdhouses did he make? He made 15. So we can say 80 multiplied by 15. And so if you had to go calculate all of that, it's going to be 1,550 Rand. So that is what his expenses were for that week. Now we need to try to see what his income will be. Okay, so now we know that he sells 12 birdhouses. So we can go to 12 on this table, this annexure, and we can go up here to the income, okay? And then we can go across. Okay, now you can't really read it off, but this would be 1,600. This would be 1,700. Then this would be 1,800. Okay, so his income from the graph, we can say 1,800. So if you look at this carefully, his expenses was 1,550 and his income was 1,800. So we can say that his income is larger than expenses. So we can say he made a profit. He made a profit. Okay, and then we would have to also just go and calculate that profit. So we could say 1,800 minus 1,550, and that's going to be 250 Rand profit. This question says that Danny and Susan are on their way to visit some of the tourist locations in Japan. Annexure E, which is this one over here, shows a road infographic on their planned tour with the various tourist locations that would be visited. Okay. The tourist location details in random order for the tour are given below. So they say starts in Tokyo, visit Mount Fiji, blah, 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 blah. It says here, complete the table below by inserting the tourist location details in the correct order. Location details for 01 and 06 have been given. Okay, so let's try to see what's actually going on here. So for location 01, they said that that was A, which was start in Tokyo. Okay, and then for, so that one's done, right? So then for 06, which is down here, they already filled that in as E. So that is the trip will end at Itsekushima, which is known for the Great Torii Gate that is standing in water at high tide. Okay, so they've done that one for us. So thank you very much, but that's also now done. So we need to go figure out the rest. Okay, so we can do 02 now, okay? So 02 is over there. So 02's got this 40 over there. You see that? And then I saw that there was something here with a 40. It says drive through Kamakura at a speed not exceeding 40. So that's that one over there. So we'd put an F over here. Okay, then 03. 03 is definitely got to do with the mountain. So that would be Mount Fuji. So that would be B over here. And then, okay, so that one's done, that one's done. Then 04, 04, okay, well, we've done this one as well, and we've done that one, and we've done B. Okay, so what's left? There's an aquarium. Okay, well, the aquarium is with the fish, right? So that's going to be 05. So 05 would be the aquarium. So that's going to be C down there. So that's now done. Oh, and then we've also done E, hey? We've also done E. Oh, well, then the only one left over is D, of course. So 04, let's just see if that makes sense. They plan to visit the large wooden temple. Okay, so I guess that's the large wooden temple over there. All right, so it's A, F, B, D, C, and then E. Let me write that again for you. A, F, B, D, C, E. This question says that Mount Fuji is an active volcano. The last volcanic eruption was on 16 December 1707, and it followed several weeks after an earthquake, which was on 11 November 1707. Calculate how many decades means 10, Mount Fuji erupted. Okay, well, it's now... okay, so when these learners wrote this exam, this was part of a 2022 exam. Okay, so 2022, take away, which one was it? Mount Fuji erupted in 1707. Okay, so if you do that on your calculator, that's 315 years. So if you want to work out the decade, you can then divide that by 10, which would be 31,5 decades. Okay, and then the next one. Write down the total number of days between the earthquake and the volcanic eruption. So the earthquake and the volcanic eruption. Okay, so we're going from 11 November and we're going up to 16 December. And what's important is said how many days between, okay? So it's between, so that means we're actually going... we're not going to count the 11th of November, so you're going to have 12 November, 13 November, 14 November, all the way up to 30 November. That is how many days there are in November. There's 30. So if you had to just spend a bit of time looking at this, to go from 12 to 30, and you starting at 12, that is going to be 19 days. Okay, so it's going to be 19 days over there. You might say it's 18, but just go double check for yourself and you'll see what I mean. There's 19 days over there. Then we're going to go all the way from 1 December up to 15 December. We're not going to go up to 16 December because they said between. They didn't say including those days. So that's going to be another 15 days. So that's 15 days. So then if you say 15 days plus 19 days... that'll give you a total of 34 days. A lot of you would have gotten 35. I don't blame you. That is a bit weird. But just double check it carefully. Because they're saying between, we're going to start at 12 and we're not going to include 16 either. So this question is going to come in parts. So it's this part over here and then that part over there. Okay, so it says that in Tokyo, they will visit. Okay, so when they say they, there was a question 5.2 before this one in this exam, but you don't need to know what that question was all about. So trust me, we can do this question as a standalone question. So in Tokyo, you can just think of these people. In Tokyo, these people will visit the Tokyo Tower, which is a communication and observation tower. The tower is that many feet tall with 2 viewing decks. The main deck is 150 above the ground. And the top deck is 250 meters above the ground. Okay, so let's go see what the first question says. Write in simplified form the ratio of the height above the ground of the main deck to the top deck. So they're saying main deck first. So main deck was 150. And then the top deck was 250. But now they said in simplified form. So you can simplify this a little bit. What number can go into both of these? Well, one number is 50. So 50 can go into here 3 times. And 50 can go into here 5 times. And so that, and can 3 to 5 go any smaller? No, it can't. So that is the most simplified answer. This question says, convert in meters the height of the tower if 1 meter is equal to 3,281 feet. Okay, so let's see what they're saying here. So convert the height of the tower. Oh, okay, so the tower was here. It was given in feet. So that's going to be 1092,1916 feet. Okay, now we know that 1 meter is the same as 3,281 feet. So what we could do, I mean, there's multiple ways of doing this. One way is to realize is that the meter number is always going to be smaller than the feet. You see, if the feet is 3,281, then the meter is only 1. So the meter number is always smaller. So the meter number is smaller. Okay, so if this is feet, then to get that into meters, you're going to divide by 3.281. And if you work that out, you're going to end up with 332 meters and 332,88 meters. With this question, it said Danny stated that if they had been in a group of 60 people observing from the main deck, they could have received 30% discount on an adult ticket. Verify whether his statement is correct. Okay, so it's pretty straightforward. So we know from previous questions that this question is all about Danny and Susan. So they're only 2 people. So when they go to the main deck, because they're saying here that they go to the main deck, they're just going to pay the normal adult price for the main deck, which is 1,200 yen. Okay, so the original price is 1,200 yen. Now, if you're a group of 20 people, but less than 50, then you can pay this amount. But here we go. If you are a group of 50 or more, so that's where you would get if you were 60 people, right? Then the adults would only pay 960. So the new price is 960. So what I want us to quickly do is, let's say that the original price was 1,200, and let's see what 30% of 1,200 would be. So let's give the 1,200 a 30% discount, okay? So 30% of 1,200, so you could say 30 over 100 multiplied by 1,200, and let's see what that gives us. So that's 360 yen. So that's how much discount there would have been. So the new price then would be 1,200 minus 360, and that gives you 840 yen. But they said that the price is 960. So Danny is incorrect. Danny is incorrect. Because if you take 30%, if you take a 30% discount, let me write this a bit bigger for us. So then the new price with discount, with a 30% discount, would be equal to 1,200 minus 360, which we said was 840 yen. But they said that you're gonna still have to pay 960, not 840. So he's not correct. On their return journey, Danny and Susan took a train from Hiroshima to Tokyo. The train leaves Hiroshima at 8:06. It stopped at 8 stations for 4 minutes at a time. It reaches Tokyo at 12:03. The distance the train travels is that. Calculate the speed at which the train travels. Okay, so it says you can use this formula. So if you take that formula, distance, I'm just going to say D is equal to S multiplied by T. If you want to get S by itself, then that's going to become D divided by T. Okay? So that's the formula we're going to use. Distance divided by time. So we know the distance, it's 816. So we need to work out the time. But remember, the time you need to work out is the time that the train is actually traveling, not the time that the train has also stopped at the station. So this train left at 8 12:06, and it traveled all the way until 12:03. But remember, in between, it did stop 8 times. Okay, so we'll look at that shortly. But let's quickly work out how long this is. So this is going to be 3 hours and then 57 minutes. Okay, because 3 hours would take you to 11:06, and then if you add 57 minutes, or if you add 54 minutes and then another 3 minutes, it will take you to 12:03. Okay, so that's how long it traveled for. But it stopped 8 times for 4 minutes every single time. So the stoppage time would be 8 times 4, which is 32 minutes. So what would the travel time be? The travel time would then be 3 hours and 57 minutes. Take away 32 minutes, and that's going to give us 3 hours and 25 minutes. Okay, but now the mistake that a lot of learners are going to do, and I've seen this many times, is they say that, okay, so now now we have the time, it's 3 hours and 25 minutes. Then they say 3.25. That is not correct, okay? You can't say that 3 hours 25 minutes is 3.25. The reason is that you need to first convert the 25 minutes into hours. So 25 minutes must be converted into hours. So that's going to be 25 over 60. And if you type that, or if you work that out, it's 0.416 recurring, okay? 0.4166666. Okay, so if you then say 3 plus 0.416 recurring, it's going to be 3.416666. And I guess we can keep like 4 decimals like that. Okay, so that is the total time. A lot of learners are going to say 3.25, but be careful with that. It's not correct. Okay, so now we can use this formula. So speed is equal to distance, which was 816 kilometers, and the total time is 3.416666. And if you had to go work this out, you would see that the speed, well, the average speed is going to be, let me write it up here, 238.83 if you round to 2 decimal places, kilometers per hour, and that is the speed.